So let's take a look at question 2. In question 2, this is still on part 1. Question 2 says you have, or this is B, you have dy over dx, which is equal to 1 over y minus x. So in this case, here you have, well, can I separate these two? This is not separable differential equation. What I'm going to do, I'm going to check to see if I can write it in linear form. So I have y minus x, y prime equals to 1. What I have y times y prime minus x, y prime equals to 1. So as you can see here, you have y times y prime. So if your function is y equals to f of x, it's not going to be linear. But if you can write x in terms of y, let's see what happens. It means that we have to flip these two. We get dx over dy equals to y minus x. So x prime becomes y minus x. So x prime plus x is y. So if your function is x equals to g of y, then you can write this in linear form. Why is that? Because here now you have a1y times x plus a0y, this is x prime, times x equals to, for example, a function in g like, in y like q of y. So as you can see here, you have a linear differential equation. So since it's a linear differential equation, it's already in standard form, find the integrating factor. So what's the integrating factor? Integrating factor is e to the power. Here you have 1 times x, 1 dy, which becomes e to y. Very good. Now multiply everything by the integrating factor, x prime e to y plus x e to y equals to e to y times y. Well, in this case, your left-hand side, here you have the dy x e to y equals to e to the y times y. If you take the integral of both sides, you get x e to the y equals to the integral of y e to y. Here we have to use integration by parts. U is y, dv e to y, du is dy, and v is e to y. dy was here. Okay, so x e to y becomes uv, v, y e y minus the integral v du ey dy. So now you have your x e to the y equals to y e to y minus e to y plus constant of integration. We can divide everything by e to y, and then x becomes y minus 1 plus c e to negative 1. Either write it this form or isolate your x on the other side.